now is the components of a Delta V Profibus solution. We have the Profibus DP interface card with one port. In this case, we have it connected to a Siemens Simmercode motor starter. The Simmercode is one of the more popular devices on Profibus. In this case, the Simmercode is wired up to a light bulb to simulate a motor. We have a switch to control the current feedback. What we're going to do now is go and look at the Delta V Explorer and how we treat Profibus devices within Delta V. So, the Delta V library, we've added a new category for Profibus devices. Under Profibus devices, we have the device types as defined in the GSD file. Under the device types, we have manufacturers. The manufacturers will have different devices, potentially, and under the devices, we support different revisions of the device. This way, if you have multiple devices that are of different revisions, we handle it in the database. What we're going to do is add a new Profibus device to the library. So I right-click on Devices, click on Add Device Definition, go to where my GSD files are. I'm going to select a GSD file for a device type, click on Add Device. This will add the device into the library. We just added the new category controllers. Under controllers, we see Eurotherm controls. Here we see the device. It's a single loop controller, the revision 1.1. And here we have the Profibus slot type. Profibus card has one port associated with it. If we look at the port properties, we see we have several choices of what we can do. We have action in event of controller failure, stop scanning or continue scanning. We have the baud rates that we can select from amongst the standard Profibus baud rates. We also have the address of the card. This allows us to move our master address out of the way of other masters. An example would be you have a configuration device which has a fixed address. We need to move our card out of the address space of that master so we don't have a master address clash. We also have advanced properties where we can define things like repeaters and other properties of the communications of the segment. Generally, you don't need to adjust these. Let's look at the devices we have defined under our Profibus port. I open the port up and I see I have a motor starter. If I select on the motor starter, again, here I see all the parameters, in this case on an instance basis. This is where I would adjust the individual characteristics of a particular device. If I open the device up, we see it has a slot. The slot has signals associated with it, and the signals have a DST. Again, exactly the same as a DST from a standard Delta V I/O card. To add a new device to the segment, I simply right-click on the port, add new Profibus device. The choices are the choices defined in the library, and we could add the new device type of controllers, or we could add another motor starter. Let's add another motor starter. I double-click, and I've just added a new device to the segment. All I need to do now is give the device a name, and we'll call this Motor 2. Give it an address on the bus. In this case, we'll pick address 7. And if I wish to make this device work, I simply tell it to be enabled. I say OK, and I've added a new device onto the Profibus segment. As soon as I download the port, this new device will be added to the segment, and I haven't affected control on any other device in this segment by doing this. So this is a fairly unique Delta V property. We can add Profibus DP devices online without affecting control and without affecting any other device. What I want to do next is look at diagnostics for my devices. If I right-click on the port and launch diagnostics, we'll see we go into the diagnostics application, and I find that I have a bad device for the Motor 2 device. This is because I've added the device to the database, I've added it to the card, but the device isn't physically present. If I wasn't sure what the reason it was bad was, I could right-click on the device and go into Display Device Information. This will give me detailed information about the characteristics of that particular device. And in this case, we see the station is non-existent, and we see that its master address is set to 0. So we know we're not communicating with this particular device. We haven't found it on the bus. Let's look at a good device for a second, the other motor starter. If I go to its device information, we'll get to see several pieces of information about it. We see that it's a slave device, it's in good status, it has no extended diagnostics, and it's talking to master 1. What I'm going to do next is generate a fault on this device. This is the fault we did earlier by breaking the feedback current. So if I switch the current off to the device, I update the diagnostics information, I go and poll the device again, we'll see the extended diagnostics bit has come on. This tells me that I need to go and look for more information. If I go to the next tab, the device level tab, we see we have a fault on the checkback current. The checkback current is off. This message we get from the GSD file. Some devices we can drill down further. We may have a slot level message or a signal level message. The signal level message would have the DST associated with it. Some devices don't give me friendly messages. So what you need to do is go to the Diagnostics Message tab, and you get to see the hex data from the diagnostics message from the device. You can also look at the input data, the output data, the configuration messages, and the parameter messages that are sent to the particular device. What we've done in Delta V is built a summary screen so that you can capture all of this information in one place, go through the information. You'll see here we say we have yes to extended diagnostics. We tell you what the extended diagnostics is. Further down we have the diagnostics message. You can print this screen, you can save it to a file, and then send it off to the device manufacturer to find out what's really going on in that particular device.